Welcome back to the next episode of Wellbeing in Practice. I'm Tanya Borowski, Head of Education here at Amrita Nutrition and your host. And today I have with me a highly esteemed fellow colleague, Dawn Waldron, who is a nutritional therapist. She's been a nutritional therapist since 2003. So highly trained. And she's joining me on the podcast today to talk about many aspects of her specialist interest in working with cancer. Welcome to the Amrita podcast, Dawn. Welcome.
Tanya, hello again. Lovely to see you. And thank you for inviting me on to speak to you today.
You're welcome. It's a pleasure to have you. So, Dawn, a lot of our listeners here are practitioners, but also are patients, clients of nutrition of our practitioners here at Amrita. And I sort of introduced you on the premise that you are a nutritional therapist, although I know that you no longer actually are in clinical practice because you spend so much of your time teaching and mentoring other practitioners, which we are hugely grateful for. But you sort of you began quite quickly having a specialist interest in working with and trying to understand cancer because you yourself have danced with this disease, and you actually you are a survivor of a grade 3 stage 3 triple negative cancer. That's correct?
That's correct, yes. When I was 33. So it was all the threes at once. And
That's right.
I often say that's when I realized that 3 wasn't my lucky number, except of course it did transform my life. And I'm not far off my 66th birthday, actually, which means that I will soon have been alive as long since cancer as I was before, which
Yay
is
to that.
pretty miraculous, really. But yes, you're right. That was my specialist. That was always my driver. I think that, funnily enough, and a bit of a lifelong weight problem, which also I felt was, even back then, I think we knew enough to know that being overweight was linked to cancer, and I knew that was a significant risk factor for me. So I've always said I have a body that doesn't obey the rules, and all of that meant that I was really interested in looking at health and breast cancer. It was a bit of a selfish motivation at first, but I went back to college. I've always loved science. I redid my A levels, in effect, a science foundation course, because I did do science A levels. And then I did the 3-year training to be a nutritional therapist. Later on, I did some postgraduate training and what have you. And I also trained to be a life coach along the way. So, which is in recognition of the fact that this is such a wide-ranging and multifactorial problem that we face as individuals, and I think as a society now.
You never sit still, which is another one of your many attributes, and you have designed your website which to reflect the work that you are doing now. And I'm going to quote a paragraph or a couple of sentences, listener, don't worry, from Dawn's new website, because it is an area that it sums up beautifully sort of 3 key areas that is going to showcase the conversation that Dawn and I would like to have around this topic. So Dawn has written, drawing on almost 30 years of personal, as she's just explained, and professional survival experience, Dawn explores the metabolism, the mindset, and the minefield of cancer prevention and recovery. And when I read that in preparation for interviewing you, I immediately thought you felt that you've drawn 3 key areas that allows us to really help to open up the dialogue around how the view of cancer, its progression, its causes, and its support, rather than, if you like, treat, and the support thereof of it, it helps to really provide an amazing framework for that. Which the word metabolism is, and again, an area that you have spent the latter part of last year really beginning to educate our industry on, and I can't thank you enough for that. And that's just the tip of it, of what your learnings are. But the word, sort of in terms of metabolism as it relates to cancer, um, could you could you begin to explain what the foundations of understanding metabolism, how important that is, and what that looks like? And before we came on air, we were talking about the absolute importance of the mitochondria being sort of central to this conversation. Could you?
Absolutely, yes, yeah, with pleasure. It's in some ways this is a huge subject, so it's not easy to sort of distill it, but I think we I think to start with, it's fair to say that we don't always know what we mean when we say metabolism.
Exactly.
The shorthand, the way we teach it in most nutrition colleges, we teach metabolism, or the metabolism lecture is the lecture that explains how we make energy.
Yep.
And so they sort of become synonymous in the minds of nutritional therapists. Funnily enough, and sadly enough, we very rarely teach biosynthesis in the same lecture or in the same series of lectures. The shame of that is that we actually, if you think of the cell as containing, I sometimes see it as a bit like a school gym, which I hated, as creating, as containing.
Well, you and I are similar ages, so you and I were probably both standing along the corners trying to do the Bagger Awards.
Absolutely, yeah, and failing miserably. Forward rolls were not for me, and anyway, so you've got the bars up the walls, you've got the horse, you've got the soft mats and all this sort of thing. So that, anyway, this is a bit of an analogy for the cell, okay? The point being that the apparatus that we use to make energy is exactly the same as the apparatus that we use for growth. Except to make energy, we use it forwards. We go around the gym one way, and to make growth, we go around the gym the opposite way, if you like. And when our cells mature, when they go through the differentiation process from stem cells, right the way back to being an embryoblast, where fundamentally it's all about growing. And we're using reverse Krebs to biosynthetically create molecules, proteins, amino acids, phospholipids, DNA, RNA, you name it, we're creating these molecules. We're using Krebs cycle to do that. And then later on, when that same cell might become a differentiated cell, a mature differentiated cell, let's say in the breast, then the mitochondria are still using Krebs cycle, but in reverse, to generate energy, primarily for gene expression, because gene expression does suck a lot of energy. And what's becoming clear is that, and let's be clear that at any point then in a mature human body, you'll have some cells doing one thing and some doing the other. It's not all cells just making ATP. But when a cell becomes cancerous, one of the hallmarks is reprogrammed metabolism, then what we see under a microscope, if you like, is that the cell, which was previously focused on making energy for gene expression, might head back towards stemness. That's often how we grade a cancer for aggressiveness, and start to obviously grow again using molecules like glutamine. So we get growth in places where we're not supposed to be growing.
Okay.
And that's one way we can look at cancer. And so a fundamental understanding of that metabolism is actually very important for everybody who tries to help people with cancer. So, and while we can say that cancers are very definitely caused by a variety of things, they might be caused by genetic mutations, not as frequently as is said, and certainly not always. They might be caused by viruses. They might be caused by toxic exposure, like X-rays and smoking. But they can also be caused by energy overload, by a failure of the mechanisms in the cell, the apparatus in the cell,
Yep.
to run the right way round. Furthermore, while we can't always avoid exposure to some of these things that might cause cancer, and we can definitely say, well, that there are various. Almost any cancer can be helped by trying to support the cell metabolically. So that, to me, is the central focus, that no matter what else we're doing for a cancer patient to help them overcome their problem, whether we are using conventional treatment or not, or things like hyperbaric oxygen or intravenous vitamin C, etc., all the things that we're learning about, we should, at the very least and at the most fundamental, be supporting optimal mitochondrial function, helping the cell to go around the gym in a forwards direction rather than a reverse direction, if you like.
I absolutely, and I've personally heard you talk about metabolism, explain metabolism a number of times. I mean, I would say about 10 to a dozen. But this analogy, I haven't heard you use the gym apparatus analogy before. I don't know whether this came to you over the festive season. But for me, it's another penny that drops. And in terms of, and we talk about this in education a lot, don't we? In terms of that, there is always, so cleaning, if you like, or freeing the apparatus, or apparatus, which is essentially the health and the integrity of the mitochondria, is freeing that apparatus to be able to flux in the right direction.
Exactly that, yes. And I think core to that is a very important biochemical reality, or a biochemical concept, which is, if you've done any chemistry or biochemistry and you've looked at the building equations for chemicals, you know that generally speaking, a biochemical reaction will move from an area of high concentration to low concentration.
Yes.
So it's a fundamental. No one's going to argue with that, basically. There are one or two exceptions where it doesn't work that way, but on balance, you're not going to argue with that. So what we find happening with within the mitochondria is when we get when the mitochondria are not working properly, we get a buildup of molecules. So one such molecule is succinate, for example, which can build up when the mitochondria is not pushing forward properly, when the mitochondrial energy-making complexes are slowed down. There are lots of reasons for that. There might be a buildup of protons. It's no point getting too complicated about that. But if the push through, if there are too many people building up to use the bars on the wall of the gym, it makes sense for something to start to go in reverse, if you like.
Yes.
So the teacher's going to say, no, go and use the horse, or go and do some forward rolls on the mat or something, because there are too many people. And so, so basically the cell very logically says, okay, right, we can't push this through, and we're in danger here. There's a problem. This is going to blow if we're not careful. We need to go in reverse. It's really it's sort of, in a way, it's horribly oversimplifying, but the point is that biochemically, even at the basic rules of chemistry levels, there is a good reason why we might end up going into reverse Krebs, and that the cell then becomes, the cell can't function as it should do. So that's a bit, yes, that's a bit like staying. That's a bit of a cleanup operation. We know, for example, that succinate is an oncometabolite. We haven't always understood why. The gut bacteria can produce a lot of succinate if we have a dysbiotic microbiome, for example, and that can get in the way. So yes, once we, but the fundamental thing is understanding what happens when these oncometabolites build up, and that the cell starts to go, okay, guys, we can't make energy anymore. Let's see if we can grow.
And that is, in essence, would it be fair to say that then is it can begin a domino effect of the cell going rogue for
yes,
yeah,
very much so, because in fact what my reading indicates is happening then is that we get some epigenetic effects.
yep.
Succinate in particular activates some genes that then keep the cell in reverse metabolism, in reverse Krebs. And so it becomes very hard to reverse that. Plus, this reverse Krebs activity, which is a growth cycle, is what we call autocatalytic, which means that as well as creating molecules, it also generates the original molecule again. So it both feeds growth of new molecules, and it feeds the cycle. So one of the hallmarks, which is sort of endless replication, if you like, is very aptly explained by this model. In fact, most of the hallmarks, no, I would go as far as to say all of the hallmarks can be explained by this model, whereas actually that's not the case for the somatic mutation theory. We cannot explain all of the hallmarks using a genetic model, but we can using a mitochondrial reverse Krebs model. So I find that quite persuasive.
I find it incredibly persuasive, and an amazing segue into, because your most recent Substack post, on which, if any of you, which we will give a big shout out to, but Dawn writes the most incredible Substack account, which it is the best value for money, and it's called Uncoupling Cancer. And her most recent post was about the hallmarks of cancer, or the hallmarks of cancer. So which you've just mentioned. So, and I know, again, this is a huge topic, but are you able to explain, so what you've just said explains the hallmarks of cancer. Can you broadly explain the hallmarks of cancer and where we are today in terms of our view?
Sure, yes, I can try and link it. So the hallmarks of cancer is the most amazing piece of work. I think we all know, don't we, that we've been floundering around in the world of cancer for more than half a century, really. There's been the most massive increase. And I think they now say that 1 in 2 of us are going to be dealing with cancer and hopefully living with cancer, but actually hopefully not living with cancer, learning how to avoid it. But in the middle of all that confusion, or actually, perhaps I should say at the beginning of all that confusion, sort of somewhat coincidentally, DNA was discovered, the crystalline form. We knew that there was something sort of similar to DNA, or something that did a DNA's job from the 1800s, but we discovered its format in the 1950s, famously ascribed to Watson and Crick, but controversially, perhaps there was a woman involved earlier on, in actual fact. But anyway, so we learnt that DNA was some sort of coding system that was responsible for protein synthesis, and we were very happy to call that the blueprint for life. And that coincided with our knowledge that there were some mutations that were frequently found in cancer tumours. Those two became inextricably linked. Those two theories became inextricably linked. You know, biology is often limited by how far we can see, how deeply the imaging techniques that we have can go into the cell. And how deep our understanding of healthy human metabolism is. So it's not surprising that this amazing discovery of DNA was thought it's going to give us the answer to cancer. Well, we had the Human Genome Project, which sort of spat out its findings at the turn of the century, but it didn't give us the cause of cancer. And around that time, Hanahan and Weinberg took on the huge task of, because we couldn't have a cause, because we didn't know a cause, they said, well, look, let's look at what the hallmarks are. Let's just actually try to define what cancer is, how cancer behaves, so that biologists can rally round those descriptions and look for underlying causes. And so began a series of 3 papers in 2001, 2012, and 2022, defining what have ended up being 14 hallmarks of cancer. And those papers share an underlying assumption that we are looking for a genetic mutation to explain them. However, as is the case often in biology, the hallmarks theories, incredibly useful bodies of work, but that original seeing DNA mutation as the enabling factor of it all, we don't really see DNA in that way anymore. It's no longer our blueprint. We need to start seeing DNA as providers of molecules. So it's a bit like a lending library, perhaps, or even sometimes I see it a bit like a kitchen. I see DNA as a sort of kitchen that says, okay, here you go, you can have some of this protein, that protein, and then the body decides what to do with those proteins according to the prevailing conditions. And even more importantly, the prevailing conditions tell the kitchen what's needed. Yeah, so okay. It is so redundant now to think that DNA is the thing that controls how we respond to life. DNA doesn't have eyes and ears. Yeah. So it is there as a resource to make the proteins that we ask for. Yeah. So no, I get that. And if you eat fish and chips and a deep fried Mars bar, you're asking for very different proteins than if you eat poached salmon and broccoli and some blueberries, for example. And so we understand more and more that it's the environment. And actually, this book on my desk, which is I talk about a lot, how life works, by Philip Ball. Honestly, totally mind-blowing. I'm not sure I would recommend you to read it, actually, if you want to have a nice year. But nevertheless, it is. I'm on my second read through of it. The first time I sort of ended up in a quivering heap on the floor, thinking that everything I'd ever learned was actually rubbish. And I had no frameworks on which to pin my knowledge. Second time round, I'm starting to see he's just making a case really for, we can't say it's genes, we can't really even say it's metabolism. It's everything everywhere all at once. So we can't, and we need to embrace this holistic um this holistic way of looking at life, and you know, get back as close to nature as we possibly can. We need to understand that ultra processed foods ask our genes to do impossible triple back somersaults, or actually give our genes no instructions at all. And that's not okay. We've got to stop. We have got to stop doing that. It's not funny anymore.
Gosh, that brings up so many, everything that you just said brings up so many questions, and also illuminates so many light bulbs for me. And so therefore, I'm sure our listeners. So thank you for, as always, taking such a complex topic and being able to at least open the door to it, to allow us to think about, to start to engage with it, because sometimes these topics, and that's what you do so well, is that you allow us you actually give us the route and the authority to be able to step over the threshold of a topic that can feel so overwhelming. But actually what you do is you're able to inspire and get people to ask questions about how this could be relevant to them, whether that's you as a patient or a client, whatever term you would choose to use, or as a practitioner in whatever realm, to be able to see how this topic is relevant. And what you've sort of explained is that the way that we view it's really the way that we view medicine. And of course we are so grateful for the advances that medicine has become, but actually in our world, by this desire to label and to put everything down to a single mechanism or a particular cause, could be somewhat futile, because actually it is, as you've said, everything and anything all at once, and that in each individual is incredibly different, day to day, second to second, minute to minute, responding in that way.
I think another way of looking at it is that we are light years away from being able to code the human operating system.
Yeah.
And our somewhat arrogant attempts to think that we've done that are not helping us. And until we have done that piece of work, and I personally don't think it's going to happen before we before the human organism moves on, really. What we need to do is calm down a bit and live within the planetary constraints that we've been given. So we need to understand that we evolved, no matter how technically advanced we are, we actually still evolved from that original symbiotic event where, you know, a bacteria jumped inside a eukaryotic cell, and from there some higher levels of cooperation were available, but that we have not and will not escape the need to cooperate with our planet. And to the extent that we think we can, and that we're divorced from that, and we can make artificial food molecules and get all our exercise in the gym and all our artificial light and our artificial fibers and our artificial so plastics and all this sort of thing, to the extent that we are doing this sort of approximated human life that is so much more technologically advanced, the more we are somehow moving away from the constraints of being a healthy organism.
Yeah.
So there may be some evolution somewhere along that path for us. But
So do you think this is, well, no, it's not. So do you think somewhere along, the line we have stepped over a threshold of, so there's no argument that the human life is better, is more, the organism is more robust than it was when we were living in as cave women, and we were in also Victorian era where disease was much more rife. But if we then fast forward to where we are today in this world of biohacking and labels and sort of and a lot of man-made synthetic food lifestyle intervention, as you've just said, rather than going for a walk in nature with purpose, sort of being obsessed with running on buying a £1,000 or however much it is Peloton and sticking it in a room and running on a treadmill. It's actually, when you think about it like that, just seems really quite bizarre.
It does seem a bit bizarre, I think. And I think, the answer to your question is, I don't want to be, I don't want to be miserable about it, but it's possible to think that we may have peaked.
Interesting.
So it is, there's quite a lot of data to suggest that longevity might, for the average person, that longevity might be coming back down the other side. Our children may not live as long as we do, and obviously there are signs in the planet as a whole that life is not as conducive to human habitation and health and longevity as it used to be. So I think, look, I completely believe in human ingenuity, human intelligence, human genius. And I know from a lot of the things I'm reading that there are some amazing minds out there who are bent on creating a better future for us. But I think that future is inescapably linked to the health of the planet and to the rhythms of nature, and that's one of the realities. I think we lost that in the 20th century. I think perhaps I would go so far as to say that with our very intellectual rejection of spirituality and religion, which I don't consider myself to be religious, although I was brought up to be religious. I think we lost something there. I think we also rejected our embracing of science over spirituality or mysticism or whatever you would call it. I think we lost sight of the importance of, I don't know, consciousness or emotional connection. So that science, if science doesn't consider the emotional state of the human organism, it has got something massively missing. And something I was reading recently, I think in the Philip Ball book, if I remember rightly, was sort of discussing this idea that if we can fairly easily say that, but not everybody would agree with this, that a rock is not a conscious being. And that humans are. So, and I think we can probably all agree that humans are a conscious being.
Yes.
And I've deliberately not talked about animals and things because people have quite different views on that. But I know my dog feels emotions, that's for sure. Yes. Anyway, so if we're conscious beings, where does that sit? At what level of unit does consciousness arise? Because we're pretty sure now it's not in our brain, which would have been, and before that we might have even thought it was in our hearts, but we can't actually locate it to an organ. So at what point would we say we need to take consciousness into account? And that's increasingly looking like it needs to be at a cellular level. So therefore, a lot of science which seeks to, and a lot of medicine which doesn't take into account the affect of the patient. Again, and that's partly why when I talk about my blog, I talk about exploring the mindset as
Yes. Yes.
well.
Yeah.
And
I
also
totally see
this,
that.
who is it I've just come across looking for his book now, sitting on my shelf ready to read. I've read one of his books. There's another one coming along. I want to say Robert Davy. Anyway, but he's a neuroscientist, and his work in understanding the way our thoughts and so he's an eminent neuroscientist, brain surgeon, etc. So he's got all of those credentials, but he also is showing that the thoughts that our brain has
Yeah.
also massively affect outcomes. So it's not just going in there with a scalpel and cutting out a few cells,
Yeah. Yeah.
or doing it. It is also the thoughts involved in the brain, as well as the structure of the brain, that he's interested in for health outcomes. And I say, so that's what I'm excited about this century. I'm excited about all of this coming together. And I think,
Yes.
as we were talking about the other day, the idea that people like us, and I'm whatever that means, I'm not going to define that any further, but people like you and me, Tanya, and a lot of the people that we network with and love, um, have been apologists for a long time, and we've been fighting those outdated notions of 20th century science, and we've been saying no, you need to take more things into account than just this, and the human spirit and human biology is so much more touchy-feely, if you like. I'd even go as far as to say woo, than we have been given credit for, and actually have been roundly criticized for. And
Yeah.
the 21st century is the point where we are going to have to sit up and say, oh, actually, that is important after all.
Yeah. I absolutely love that. And so this conversation has brought in therein everything that we've just discussed is the minefield, because it's throwing what we thought we knew, in a way, and we talked off camera a bit before this in terms of the arrogance that we as a human race have in general at this point in time, that actually we are far superior than where medicine was, or where the human life was even 50 years ago. There is this sort of
Yes, yeah,
there is an arrogance to that, and this creates the minefield. And we've circled back into absolutely the importance of the mindset, and how all of these incredible authors that you are showcasing and that you use to educate yourself we're seeing and validating again and again of how powerful the mindset is to overall health, at a cellular level,
absolutely right. And actually, the other thing that cropped up as you were saying that is a little dialogue that goes on in my head, which is that going back about 15 years, I think I was being directed very strongly to stop reading books for scientific opinion, and to refer only to original papers and randomized controlled trials and the like, and to read everything in the original, which has served me very well, I have to say. My Mendeley library is quite bonkers. However, what I have found in the last 2 or 3 years is that if we're talking about proliferation, which we are with cancer, obviously, the proliferation of science is actually quite bonkers too. And the ability to feel your way with randomized controlled trials or similar types of epidemiological studies and things like that, or systematic reviews, etc., is increasingly difficult. And one thing I would say to therapists, to practitioners, is find some thought leaders as well, to direct your studies, because we need these people who have this overview and who have
Yeah.
long careers, who are able to synthesize ideas and look at the direction of travel for ideas and science, because I think no longer can we just rely on RCTs to inform our view and to help us see the big picture.
Beautifully put. So before I let you go, I know that you are working on a project to deliver mid yeah, anyway, we won't put a date on it, but you are looking to deliver a project to help support, to provide help practitioner, nutritional therapists use their tools in an elegant and in a way sort of to gain more confidence, to go back into the confidence of using the tools that nutritional therapists have in their kit bag to support clients with cancer. How do you see what do you see is missing in the nutritional therapy arena, in or how nutritional therapists are thought of in this arena, and how are you going to help support them so that the art of nutritional therapy can be reapplied?
That's a great question, because we know that Macmillan published a report about the rehabilitation 6 or 7 years ago now, and that the Professional Standards Agency have been recommending multidisciplinary teams in cancer for a very long time now, and we're not seeing that happening on the ground. We also know, and I know from firsthand experience and client reported experience, that oncologists often roll their eyes if nutrition is even mentioned, and sometimes get angry. So how do we close the gap there? One of the things we need to do is we need to understand the benefits of nutritional therapy, but it's also vitally important that we understand the boundaries.
Yes.
So there is no question in my mind, as I mentioned earlier, that mitochondrial support is very, very important for all clients, for all patients going through cancer, for prevention, through treatment, but with great care, and certainly from as soon as you hit the ground running after treatment. The bit through treatment needs incredibly expert guidance. And if you're not that therapist, if you haven't got a really thoroughgoing understanding of the drugs and the way treatment works, then I would respectfully say you should step out of that arena, and you should be referring to people who do know about that, because otherwise we do risk actually giving our profession a bad name.
Absolutely.
But there is so much we can do for prevention, but more importantly for recovery. There is a massive population of people living with and living beyond cancer now, who are no longer medicated. If you're really interested in cancer, that's a great place to start. And I will be helping. I'm currently putting together a training program for nutritional therapists that will help with that. I can't give you a date yet, because you can see from the enormity of my thinking at the moment, I haven't quite narrowed down almost the domain that we're going to be working in, and I haven't sorted out all of the boundaries at this point.
But you are developing a course. We can say that. You are
absolutely,
which is amazing.
And in a way, it already exists, but I've just got to get it on paper. if that makes sense.
Yeah.
So that's going to happen sometime this year for sure. And it will be part of my aim this year, because I really want, as you can see, I believe that metabolic therapy can help all of the cancer patients all of the time. But when a cancer patient is going through treatment, they are sometimes taking drugs which are not compatible with being healthy. They're not compatible with our
Sure.
healthy aims, because they're deliberately trying to kill cells, and they're deliberately trying to maybe reduce antioxidant availability in the body and things like that. It's really important that if a cancer patient submits themselves to that treatment, we're not the ones who get in the way of it. Partly because of a lack of understanding, and partly because of a lack of patient understanding. So I'd say that to patients too. If you want to work with a nutritional therapist, make sure you're working with somebody who really understands that there are risks involved, and be courteous to your oncologist. Be guided by them. I'm not sure I'm very in favour of the eye rolling and that patronising thing that can happen, obviously, but nevertheless, please do be aware that you can undermine your own treatment aims. And believe me, having been through really severe chemotherapy and radiotherapy, it's grim enough without actually watering it down by taking too many antioxidants or boosting methylation at the wrong time and things like that. So we do need to be careful about that.
Yeah, and it is a huge topic, and that's why I sort of brought it up at but it's at the end, in terms of that
very
there
important.
is what everybody will absolutely, hopefully I know, will be on the edge of their seat saying, I want to learn from this woman. I want to be, it's the equivalent of, I want to be guided by how would Dawn approach this. And that is what I really passionately believe this is what our industry needs. Because you and I both have talked about this, that some elements of it have wandered into the medical arena with the framework of functional medicine, because medicine is in the title, and there is this sadness that it has left the beautiful art of nutritional therapy behind as sort of like as a poor cousin. And actually what we are both very passionate about is bringing nutritional therapy back into center stage. And if you would like to work with and support clients with cancer and post their treatment, then what Dawn is offering is a framework, and allow her the time to create, because the more time you allow her when it comes live, it will be absolutely worthwhile. But it's a framework that will allow this beautiful modality that we've all trained in to come back into center stage, and not to have our heads turned maybe so much by more shiny terms, and that actually, and utilize the qualification that we trained in the right way.
Absolutely. Yeah. And I think, we can't always win. The world of nutritional oncology lost a very shining soul last week in Patricia Daly, and she defied the odds for 16 years without surgery, and she had a particularly aggressive form of cancer that is, I know because I've lost another friend to it, which is particularly intractable and has an extremely predictable return time. So she did exceptionally well. But I guess I just always want to say, I'm also not coming from a place of saying we can always win.
Oh gosh,
but
no.
we can do so much better.
Incredible. Dawn, thank you so much. You are just the most incredible asset. You play the most incredible contribution to this industry, and thank you so much for coming on here and sharing a tiny glimmer into your amazing brain. And thank you in advance for, I know, the incredible work that you will put into developing this course and this qualification that will form a really important part of nutritional therapy. Maybe get you back on when it's being launched so you can talk
Lovely.
through it. I think that would be a great thing to do. And wish you a really successful and get stuck back into that book again now, 2025.
Thank you. Thank you, Tanya. Lovely to
Okay.
speak to you.
Lovely to speak to you.